This video presents our solution to design and implement advanced control for maximum motor utilization. Electric motors, eMotors, play a very important role in a wide range of applications from home appliance to automotive and aerospace industries. For the optimization of functional behavior, cost and performance of large and complex eMotors, it is necessary to verify and validate their drive and control systems. Indeed, once the motor is designed, two key questions come up. The first one is how to evaluate the motor performance, such as the torque, power, or speed parameters, in a motor drive environment. The second is how to obtain maximum motor torque, speed, and power with high efficiency. The solution we will present is based on a model-based design approach combining the use of the Motor Control Design Suite, MCDS, and JMAG-RT motor models. In this presentation, we will specifically detail how to design a control loop by using the MCDS of Psim. Let's start with a quick introduction of the JMAG-RT module of JMAG, a comprehensive electromagnetic platform. In JMAG, you can design your motor with JMAG Designer module and test it to assess the power losses, for instance. As soon as the motor answers your specifications, you can export the model with JMAG-RT to be simulated in Psim. The motor models from JMAG-RT will provide a high level of fidelity and accuracy by taking into account all the nonlinear effects such as saturation and spatial harmonics. Once the motor is designed, it is imported in the Motor Control Design Suite of Psim. The MCDS is an add-on module of Psim that allows the design of the control loop of any motors in very short time, just a few minutes. This suite enables engineers to maximize the utilization of the motor and drive the motor to the limit with the best advanced motor control methods. In this add-on module of Psim, you will be able to represent the real-life motor that exhibits nonlinear behaviors. The nonlinear motor control of the suite is adapted to control the motor model designed by JMAG. It also enables the motor to operate at very high speed. The MTPA control, field weakening control, and MTPV control of the motor control drive template enable to achieve the best drive performance possible. Finally, the thermal module of Psim will help assess the losses and achieve the motor drive system efficiency. To conclude this brief introduction on the MCDS, just keep in mind that this module allows to design the control loop of any motors in few minutes. This suite enables engineers to maximize the utilization of the motor and drive the motor to the limit with the best advanced motor control methods. As you may know, control loop design of a permanent magnet synchronous motor, PM-South-M, drive could ask some efforts and time for any engineers. First, it involves the design of the inner current loop and outer speed loop. Then engineers need to take into account the motor nonlinearity and other factors, such as switching frequencies and sampling frequencies, motor and drive efficiencies. Finally, the optimum performance and advanced control algorithms need to be developed and implemented. The Motor Control Design Suite in Psim makes all those tasks very easy and help users save time. Based on minimum system specifications, the suite automatically designs all the controllers for speed and current loops with proper specified crossover frequencies and stability margins, and with advanced control algorithms such as maximum torque per ampere, MTPA, control, field weakening control, and maximum torque per volt, MTPV, control. It will generate a complete system that is operational and ready to simulate in a few minutes. Let's see, with Adrian Michel, our power electronics lead engineer, how to use the Motor Control Design Suite in Psim to design a drive for a 100 kW PMSM.
For this example, we will implement a drive for a 100 kW PMSM. To start with, have a look into the entire system. First, we have the voltage source, which is in fact the DC bus. We have here the inverter model, which is an ideal one. We have the three sensors, the three current sensors, which will feed the motor. We have the PMSM from JMAG-RT. So this motor model is derived from JMAG software, giving a high level of fidelity and accuracy as compared to the actual linear motor, taking into account all the nonlinear effects such as saturation and spatial harmonics. We have also the mechanical load here. We have also at the bottom all the complete control algorithm. For example, we have the speed controller subcircuits. We have the MPTA, field weakening control, and MPTV control algorithm implemented in this block. We have also the current controller, including some PI blocks. We have the PWM directly there, which will feed the inverter. And on the left side, we have the parameter panel window, including the main parameters to tune in order to design correctly the control loop of the motor. So we can find the description of those parameters into the parameter file block here, basically here. So we have the DC bus, the inverter parameters with the switching frequency and current. We have the load parameters, the motor one, and the motor controller. Of course, you can tune all of those parameters, and you will need to click on Update Parameter File. So, in fact, this button will update the system parameters for simulation. In fact, the parameter file contains the parameters entered by the user and the ones calculated by the design suite. Indeed, the parameters of the current loop and the speed loop controllers are calculated automatically, saving users a lot of time and effort in designing the controller themselves. So if any of those parameters in the parameter panel are changed, you have to click on Update Parameter File again to update this file. And as you can see, all the PI values and other needed parameters are calculated automatically for feeding the control algorithm part. One very interesting thing is the speed torque curve button. In fact, once all input parameters are entered, we have to click on this button in order to check the maximum torque and power that the system could deliver. So based on your parameter filling, this button will automatically show you the maximum torque and power depending on the speed applied. You can modify the DC bus and the inverter current, and you can see how these changes, for example, will affect those curves. As you can see, thanks to the control algorithm implemented, we can still have torque and power in high speed region. So now let's run this simulation. And if needed, we can still tune the value of frequencies if we think there are still some small miscalculation in the control design algorithm. So here the simulation is running. We can see the current, the speed, the VMA, torque, for example. After the simulation is completed, we can observe in SimView all the results. So we have applied a 6,000 RPM as a speed reference. So now if you go back into SimView, we can see that the speed will reach our reference as requested as well. We can also check the different current which are feeding the motor, which are all sinusoidal. We have also the torque value, and we can clearly identify the torque ripple due to special harmonics. And also we have the MPTA and feed weakening control algorithm. So before 0.6 seconds, we have this MPTA mode, and after this time, we would get the feed weakening control. If we want now, we can change the speed reference at 3000 RPM, and we can directly observe the result of the speed. So we can see that the speed is well achieving this 3000 RPM. So my control is working well. So the next step now will be to calculate the efficiency of the entire motor drive. Indeed, the power losses of the PMSM motor, including copper loss and core loss, can be obtained from the JMAG-RT model. And the power loss of the drive, including switching loss and conduction loss, can also be obtained from IGBT thermal module during the simulation, plus the junction temperature as well. And at the end, the PMSM drive system power loss and efficiency can be easily calculated from the power losses of the PMSM and its drive. And we can basically obtain the overall drive system efficiency for this system.
To recap, as demonstrated by Adrian, design your motor in JMAG. Implement it in Psim. Then design automatically the drive of this motor with the Motor Control Design Suite. Finally, simulate the whole system to observe the speed and the torque. The coupling between JMAG and Psim is the ideal solution to quickly and accurately drive control implementations with advanced control for maximum motor utilization. If you are interested to get a trial version of the Motor Control Design Suite, there are 2 ways to contact us. By email at sales@powersys-solutions.com or by scanning the QR code and filling in the Contact Us form.